So what we have, again, we want to find out the z value, the number on the z-axis that corresponds to 17.2 on the x-axis. Now the x-axis and the z-axis are the same axis, but they're numbered differently. So what's the numbering in the z? What's the z numbering of the point for which the x numbering is 17.2? Well, I've drawn a picture over here. Here's our z, and I've got 0, 1, and 2 because that's the relevant part of the axis for these numbers. Okay? Now, I've also got my x numbers here. So that z equals 1 corresponds to x equals 18, z equals 2 corresponds to x equals 20, z equals 0 corresponds to x equals 16. Well, if I draw an arrow from here to here, then that's how far 17.2 is from the axis of symmetry, if you like, or the mean value, which for x is 16, for z it's 0. Okay? Then the 18.6, I could draw an arrow. And this arrow shows us how far this number is from the mean. Okay, well, this distance on the x axis is 17.2 minus 16. Clearly this distance is 1.2. This distance is what? Think it through yourself, okay? It's 2.6. Okay? Now, how many standard deviations is each of these numbers from the mean? I say it like this: delta x. This would be a delta x between here and here. Delta x equals 1.2 is how many standard deviations? How would we answer that? Well, one standard deviation is 2. I'll say standard deviation for x is 2. And 1.2 is how many of these? Well, it's 1.2 over 2, or 0.6 standard deviations. So that when we're here, we're at 0.6 standard deviations away from the mean. Well, z is your number of standard deviations from the mean. So that means that if we come up here, z equals 0.6. Now, if we go from here to here, we have a displacement of 2.6. What is that? That's 2.6 over 2 equals 1.3 standard deviations. Now, this is 2.6 from the mean, so we're 1.3 standard deviations from the mean, meaning that z is 1.3. Now, we can plug z equals 0.6 and 1.3 into this function, get the length of this line, the length of this line. Getting the lengths of two lines allows us to estimate the area of this region. We won't get the exact area of the region because the normal curve is continually curving. And the trapezoid has only a straight line here, but the trapezoid stays pretty close to the curve in this region. Okay, well, let's go ahead and do a couple of calculations and see what the area of that trapezoid is.